Hello there, welcome to CXC Math TV. Today we will be looking at solving equations with complex solutions. So, go ahead and pause the video and attempt this question. Solve the equation z cubed minus z squared plus 3z plus 5 equal to 0. In trying to solve that question, what did you notice? Well, what we should have noticed is it's a cubic equation. So let's review some stuff that we should know about cubic. Solving cubic equation, we use factor theorem to find one root, and then we find the other two roots by polynomial division. And we know that cubic equation has 3 roots. That is what we do know. Now, the thing about this type of equation is it's a cubic equation, and whenever you're solving cubic equation with complex solution, you're going to solve the equation using factor and remainder theorem to find the first root, the real root that is, and secondly, once you get the first real root, the other two roots are going to be in the form of complex roots, and these complex roots occur in conjugate pairs. Alright, so if one root is a plus bi, then the next root is a minus bi. So then you might ask yourself, so how do I go ahead and solve this question? What do I notice? Now, let's have a look at the question. If you're to substitute z equal to minus 1 as a root, so minus 1 cubed minus minus 1 squared plus 3 times minus 1 plus 5, plug all that in your calculator, you get 0. By factor theorem, z plus 1 is then known to be a factor. Since z plus 1 is a factor, we go ahead and do our polynomial division. So we divide that cubic function by z plus 1. And after doing all of our polynomial division, we end up get that z squared minus 2z plus 5 is the factor. Then what would you normally do? Now what we can then conclude is that z squared minus 2z plus 5 times z plus 1 is equal to 0. And if the product of two numbers is 0, then we can conclude that either the z squared minus 2z plus 5 is 0 or z plus 1 is 0. Now if the quadratic part is 0, then we'd have 2 plus or minus the square root of. Then we know how to solve quadratics. We're just using the quadratic formula. So it's b squared minus 4ac inside the square root. So it's negative 2 squared minus 4 times 1 times 5 over 2. Or z is minus 1. Now solving that part right there under the square root, we're going to get negative 16. So that's 2 plus or minus the square root of negative 16 over 2. Or z is minus 1. But guess what? The square root of negative 16, we can't do that. But we can break it up as the square root of 16 times the square root of minus 1. And the square root of 16 is 4. And we call the square root of minus 1 I. So now z is 2 plus or minus 4i over 2. Or z is negative 1. Now if we divide both the numerator and the denominator by 2, we get z is 1 plus or minus 2i. Or z is minus 1. So have a look at this. Solving this cubic equation, we just get z is 1 minus 2i, or z is 1 plus 2i, or z is minus 1. Important to note, 1 minus 2i is the conjugate of 1 plus 2i, and 1 plus 2i is the conjugate of 1 minus 2i. So we must remember, when you're solving equations that are going to lead to having complex solution, you must remember first you have to use factor and remainder theorem to find the first root. And secondly, that complex roots occur in conjugate pairs. So if one root is a plus bi, then the other root is a minus bi. Hey! Now let's go ahead and look at some exam style questions. This right here says, given the quadratic equation ax squared plus bx plus c equals 0, and that it has roots alpha being 4 minus 2i and beta, find the values of a, b, and c, and hence find the quadratic equation with roots alpha squared and beta squared. Now that's a big question right there. Go ahead, pause the video, attempt question 1, Pause and attempt question number 2 as well, and pause and attempt for question number 3. Go ahead. Now let's have a look at question 1. Now given the quadratic equation ax squared plus bx plus c has roots alpha and beta, we know that complex roots occur in conjugate pair. So if one root is 4 minus 2i, then the next root is 4 plus 2i. Then now you're going to have to remember some odd math stuff and pure math unit 1. So now we remember that the equation of a quadratic is always in the form x squared minus the sum of the roots times x plus the product of the two roots. The sum is 4 minus 2i plus 4 plus 2i, because I just add the two roots alpha and beta. So the sum is 8. The product of the two roots, we multiply them. 4 minus 2i times 4 plus 2i. And so when you simplify that, you're going to get 20. So then a quadratic equation with roots alpha and beta are going to be x squared minus 8x plus 20 equal to 0. Beautiful. So we'll do the first part. The next part said state the values of a, b, and c. So a is just the coefficient of x squared, which is 1. B, the coefficient of x is negative 8. C, the constant is 20. Now, remember that a quadratic equation is in the form x squared minus the sum of the roots times x plus the product. Now, the second part said find the quadratic equation with roots alpha square and beta square. So first thing, we need to find the sum of alpha square plus beta square, and then the product of alpha square and beta square. But let's recall, alpha plus beta is 8, alpha beta is 20, alright, and we know the form that the quadratic equation is going to take. Now alpha square plus beta square is equal to alpha plus beta all square minus 2 alpha beta, and so we substitute alpha plus beta as 8 and substitute alpha beta as 20 into that equation to get 8 square minus 2 times 20, and that's 24. Now alpha square beta square is just alpha times beta all square, and 20 square is just 400. Hence, the quadratic equation with roots alpha square and beta square is x squared minus 24x plus 400 equal to 0. Beautiful. So that is question 1. Really, really, really nice. Now, just to have a look at the final answer here. So this is how you'd want to write it on an exam sheet. Find beta. You put beta there, 4 plus 2i. Tell them the quadratic equation, x squared minus 8x plus 20 being 0. Tell them what is a, b, and c. And then for the part with the quadratic equation with roots alpha square and beta square, you just write the x squared minus 24x plus 400 equal to 0. Okay, lovely. I hope you'd have gotten that question right. Now let's take a look at a more challenging one, question 2. Now given that 1 plus I is a root of the equation 4z cubed minus 4z squared plus 6c plus 2 equals 0, hence solve the equation. Now if 1 plus I is a root, then what do we know? Complex roots occur in conjugate pairs, so then 1 minus I is also a root. So now you have two roots. So the sum of those two roots is going to be 1 plus I plus 1 minus I, which is 2. And then the product of those roots, 1 plus I times 1 minus I, we expand and we get 1 minus I squared, but I squared is minus 1. So that works out to be 2. Beautiful. Now remember, we said that a quadratic equation when you have two roots is in the form x squared minus the sum of the roots plus the product. So in this case, it's going to be z squared minus the sum of the roots 2 times z plus the product of 2. Beautiful. So now we have a quadratic factor of this cubic. So now we may go ahead and divide that cubic function by the quadratic factor, and that will result in 4z plus 1. So now we can conclude that this cubic equation can be simplified to be 4z cubed minus 7z squared plus 6z plus 2 equals 0. And we can say it has factors z squared minus 2z plus 2 times 4z plus 1 equals 0. And so now the quadratic part is 0 or the linear part is 0. If the quadratic part is 0, right, we already know the solutions to that quadratic part, which is 1 plus I or 1 minus I. And then for the linear part, it is minus a quarter. Alright, so the solutions of this cubic equation is 1 plus I, 1 minus I, and z equal negative a quarter. Please note again that the complex roots occur in conjugate pair. When you're finding the roots of these equations, they occur in conjugate pairs. Let's have a look at this last one right here, which is very popular on exam. Given that u squared is negative 60 plus 30i, express u in the form x plus yi, where x and y are real numbers, and hence solve the equation z squared minus 3 minus 2i times z plus 5 minus 5i equals 0. Now to do this question, we start with u squared is negative 60 plus 30i, but they said that u is in the form x plus yi. So if u is x plus yi, let's square it. So we square x plus yi squared to get x squared minus y squared plus 2xyi. All we did was expand u squared. Now look at this. If u squared is x squared minus y squared plus 2xyi, and u squared is negative 60 plus 32i, then we can equate the real parts. So x squared minus y squared is negative 60. And we can equate imaginary parts. And so 2xy is equal to the 32. From the second equation, 2xy is 32. We can divide both sides by 2x to get y is 16 over x. Once you get y is 16 over x, you can then substitute y as 16 over x into equation 1. Beautiful. So now we have x squared minus 16 over x squared is equal to negative 60 by substituting y as 16 over x into equation 1, which is the equation with the real part. Now we just multiply through by x squared. By multiplying through by x squared, we're going to end up get x to the 4 plus 60x squared minus 256 equals 0. Of course, we'd have had to reshuffle and bring everything to one side. We can then let m be x squared, and if m is x squared, this is just a quadratic m squared plus 60m minus 256 equals 0. You may proceed and factorize m minus 4 times m plus 4 is equal to 0. Now if m is equal to 4 or m is equal to negative 64 from those factors, then it is safe to say x squared is 4 or x squared is negative 64 because we call m x squared. But look at that. X squared equal negative 64. That's crazy because x is a real number. You cannot square a real number and get a negative number. So we focus on x squared being 4. So we end up get x is negative 2 or positive 2. Now remember, y is 16 over x. So when x is negative 2, 16 over negative 2 is negative 8. Or when x is positive 2, 16 over 2 is positive 8. So now we can conclude that u is going to be x plus yi. So that's either negative 2 minus 8i or u is 2 plus 8i. Cool. So get the first part out of the way. We found u. Now let's look at the second part, which is to solve the quadratic. To solve the quadratic, just go straight ahead and use the quadratic formula, where we use b as minus b as 3 minus 2i. So we have 3 minus 2i, that's our minus b, plus or minus the square root of b squared. So we have 3 minus 2i all square minus 4 times a. A is the coefficient of z squared, which is 1, times c. C is 5 minus 5i over 2. Using the quadratic formula, underneath the square root, it's going to simplify to be 9 minus 12i plus 2i all square minus 20 plus 20i. Working out everything under that square root, it further simplifies to be minus 60 plus 32i. But remember, u square was minus 60 plus 32i. So if u square is minus 60 plus 32i, when you square root u square, you get u. But what was u? U was 2 plus 8i. or minus 2 minus 8i. So substitute the square root of minus 60 plus 32i as 2 plus 8i. And so we get z is now 3 minus 2i plus 2 plus 8i over 2, or z is 3 minus 2i minus 2 minus 8i over 2. When you simplify, you end up get 3 plus 2 is 5, and so that first part is z equal to 5 minus 6i over 2, or 3 minus 2 is 1, minus 2 minus 8i is minus 10i over 2, and so we get z is 1 minus 10i over 2. And those are the two solutions of that quadratic equation there. Really easy, nice. So, if there's anything we take away from this video, remember solving complex equations. Well, when we say complex equations, we mean solving equations that are giving you complex roots. You just need to remember complex roots occur in conjugate pair. That is your best friend. Complex roots occur in conjugate pair. Alright? So that's it for today. Stay tuned to CXC Math TV. That's it for now. See you soon and have a blessed day.